Interstellar. When I first saw this movie in 5th grade, I was pretty confused about how the main character was able to experience time slower than everybody else on Earth. Since then, a few years have passed, and in this video, I'll hopefully explain it so that Ninja can finally fall asleep at night.
7 years per hour here. Let's make it count.
During Newton's time, people didn't think that there was a speed limit to the universe, and a lot of people nowadays dream of light speed traveling portrayed in countless movies. But then Einstein decided to crush our Star Wars dreams by publishing his theory of special relativity, which basically said that Isaac Newton was a stupid idiot, no wonder why he stuck a needle in his eye, which he actually did, for some reason. Okay, that's not what special relativity said, but it also said a lot more things than just E equals mc squared. One of the things it talked about was time dilation. Imagine PewDiePie was on a bridge watching a moving car. The guy in the car called B shines a laser into a mirror attached to the ceiling and then reflects down into a detector. The detector measures how long has passed since the light was first emitted and then received. While person B did his measurement, person A was on the bridge watching person B in the car doing the same measurement as well. But instead of a vertical path, he sees a diagonal path because the car is moving. And because the speed of light is the same for all observers, the time it took for the light to reach a detector observed by A would be longer than what B observes. And if the car was moving faster, the length difference would increase, and so the difference between the observed time for A and B would also increase. In the time dilation equation, T0, or the proper time, is what observer B would measure. The Lorentz factor gamma is a function of the velocity between two observers. As the velocity increases, the Lorentz factor increases as well. At about 60% of the speed of light, it suddenly just shoots up. You can basically think of the Lorentz factor as how much faster time appears for different observers. The T on the left is what observer A would measure, and if the Lorentz factor increases, the time also increases. The reason why I told you this is because the steep increase in the Lorentz factor is how we're able to theoretically make a time machine. Let's say we wanted to go Y years in the future. You subtract the time that would pass for Earth by the proper time, or the time that you'd measure. Then you substitute the time dilation equation for T to get gamma T0 minus T0. We're just going to take off the C squared to get the velocity expressed as a percentage of the speed of light. Then we substitute the Lorentz factor equation and factor out T0. This equation now basically allows us to calculate how far into the future we travel. All we have to do is plug in the values for how long we want to stay in the time machine and how fast the time machine will be moving. So let's say you want to travel 1,000 years in the future, but you're not in the mood to wait, so the most you can wait is an hour. All you have to do is go into your time machine, set the speed to 0.999999999999928 times the speed of light, and then after an hour, you'll be 1,000 years in the future. Oh, but the bad thing is that the time travel equation only allows us to travel forwards in time and not backwards. What if we ignore the speed limit and say we've traveled at 2 times the speed of light? Would that give us a negative value, meaning that we can travel backwards? Well, no. If we said that our velocity was 2 times the speed of light and 2 squared is 4, then 1 minus 4 is negative 3. So we'd have a negative number in the root, which would give us an imaginary time. If you think about that, it sounds pretty cool. So basically, if you accidentally travel 10 billion years in the future and you're shitting yourself right now thinking, how am I gonna get back? Well, too bad. There's really nothing you can do except for subscribing. Oh, and there's one more catch. Remember that annoying equation that everybody pretends to understand? That E equals mc squared? Well, that's not even the complete equation, that's just the rest energy of an object. The complete equation would include kinetic energy, which is the energy required to accelerate that object. And that kinetic energy is mc squared times gamma minus 1. And if you remember, the Lorentz factor has a sharp increase when you reach the speed of light. Well, the kinetic energy just so happens to be dependent of gamma. So if you want to achieve light speed time travel, you would also need an insanely amount of kinetic energy. So I'm not sure what's worse, because Einstein said you can't go past the speed of light, but then he said, actually, you can time travel. But then he said, wait, you can time travel, only forwards. And then we were like, okay, fine, that's still good enough. But then just to fuck with us, he's like, but you'll never get enough energy, so don't even try it. So hopefully you found this video informative or entertaining. Thanks for watching this video, and I'll see you guys later. That phrase doesn't even make sense though, because I haven't seen anybody.